This is a scene that happens more often than it should. People use guide maps to find their way, but more often than not, these guide maps become less of a guide and more of a problem. And this is because we are not able to decode graphic illustrations correctly. The reason behind this is not because this is a very difficult thing to do, but because a few key points are not kept in mind. For example, what our two friends were not able to pinpoint was the direction to the faculty house, which is where they wanted to go, with respect to their actual position. If they had been able to fix this point on actual location, then getting their bearings was just a matter of common sense. So the point "you are here" becomes the key to decoding this particular graphic illustration. In this program today, we are going to take a look and try and analyze such and some other kinds of graphic illustrations. The situation that we just saw can now be extended to another kind of map that looks confusing: a road map. Remember, the key to decoding it is also identifying a point of reference. Here's a road map of Delhi. Let's now try and trace the route to the IGNOU campus in Maidangari from a nearby locality, Saket. This is the IGNOU campus, and this is Saket. Even in Saket, let us fix a point of reference, such as, say, Anupam Cinema, where our two friends are trying to figure out how to reach Maidangari. From Anupam Cinema, let us now move to a point A, which is a T-junction. Remember, in between there is a crossing, and don't turn on any other turn before the T-junction. Now we are at the T-junction. Well, what next? Turn left at the T-junction and move to a point B near Anupam Apartments. From here, we move right onto a small road to a point C, which is an S-curve. En route, we pass a market and the Indian Institute of Ecology and Environment. We reach the point C, the S-curve. And after passing this, we go straight down, no turns, and there is the point D, the IGNOU campus, Maidangari, our destination. So the essential point to remember is to get your bearings on the map via the point where you are. Then, faithfully following the map, keeping a lookout for the landmarks mentioned in the map, and not getting confused by other landmarks which are not mentioned in the map. Like this turn that was not mentioned in the map. Simple, isn't it? Once you know how. Well, this is one kind of graphic illustration. Sometimes we have a lot of information available to us in the form of raw data, and it becomes very difficult to try and digest it in a very short time. Also, the associations do not always become very clear. In such a case, if this information is presented in a manner that makes the information much more easily accessible, then life in general becomes so much more simple. Let me try and illustrate this with the help of an example. Let's take your academic schedule. That's your timetable. It is a table, a very simple form of table. If your timetable is presented to you in this form, which is called the raw data form, you have all the information, but it is going to take you some time to be able to pinpoint exactly the information you are looking for. Say, what you are supposed to be doing between 11 a.m. and 12 p.m. on Wednesday. If you organize this in the form of a table with rows on the horizontal axis and columns on the vertical axis, then we've got a timetable. The time is arranged on the top row and the days in the first column. Now moving down the first column, we come to the day Wednesday, and moving along this row, we come to the column for 11 a.m. and 12 p.m. And the point that is common to this gives us the period in which we are supposed to be studying English. Similarly, on Fridays, say between 1 and 2, we are again studying English. Now, if we are presented with a filled-up timetable, it becomes very easy to pinpoint exactly what we are doing when by simply moving down the column for the day and then moving across that row for the period to find out what we are doing when. Now, I know this is a very simple example, but tables, however complicated they might look, are always decoded in the same manner, and you can pinpoint whatever information you're looking for in these tables also. Let's now take another example. Let's go to the railway station, not to catch a train, but to look at a railway chart. Here too, like in any other table, the information is arranged in the form of rows and columns. On the first column is the information on the trains, and on the top row is arranged information about when they leave, from where to where, etc., etc., etc. Let's take this one. 2302 Rajdhani Express from New Delhi to Howrah, which leaves on Monday, Tuesday, Wednesday, Friday, and Saturday at 17:15 hours, that is 5:15 in the evening. So we are now in a position not only to pinpoint any information, but also to be selective about it. We can now pick and choose our information from a lot of other information that might not be of importance to us at that particular given time. So a table in a brief space gives us a lot of specific data, which avoids tedious repetitions of words and phrases, which can then be organized in the forms of rows and columns, and allows for comparisons. Yes, on to graphs. Graphs are used to simplify detailed information and help in its interpretation. Trends, movements, and distribution are better presented using graphs than using tables. A point I'd like to make here is that graphs are used to show the relationship between two variables, one pitted along the horizontal line called the x-axis, and the other pitted along the vertical line called the y-axis. A graph can be a straight line or a curved line. Let's take a closer look. Let's draw the two axes first. The horizontal is the x-axis, the vertical is the y-axis. On the y-axis, let's put the temperature in degrees Celsius. On the x-axis, the days of the month. If we plot a graph for the month of July 1991 in Delhi, then on the first, the temperature was 40 degrees Celsius, on the second, 39 degrees Celsius, on the third, 38.5 degrees Celsius, and so on. And if we join the points, we get a line graph for the month of July 1991. A look at this shows that the temperature was fairly constant between 35 to 40 degrees Celsius for the first 15 days of the month, and then fell to about 30 degrees Celsius, probably because of an inconsistent monsoon that comes by the middle of July in Delhi. If we plot on the same graph, say, the temperature in the month of July for the year before, that is 1990, then it will look like this. It shows a remarkably similar pattern to 1991, doesn't it? And a quick glance shows the comparative variations. Now, if on the same graph again we plot the temperature for the month of July for the years 1989 and 1988, then we get what is called a multi-line graph. So you can now understand the significance of this multi-line graph because it shows at a glance that in 1988, the temperature at the very beginning of the month was much lower than any of the other years. This was probably because of the early arrival of the monsoons in that year, while the year 1989 followed more or less the same pattern as 1990 and 1991. An important point to take note of is that a multi-line graph can only be formed if the two variables and the units are the same. In our example for the month of July, the two variables, day and temperature, were the same. Instead of the month of July, we can plot the temperature for different months for the same year, say 1991. And then we will get a multi-line graph which shows the temperature profile for a whole year for Delhi. What we cannot plot on this multi-line graph is, say, things like humidity and rainfall, because here the variables have changed. Another point, how many lines can be plotted onto a multi-line graph? Well, there is no hard and fast rule, but the number of lines should be such that it makes for easy understanding. If there are too many lines on the graph would appear to be crowded and jumbled. Well, so much for graphs. Let's now go on to another kind of graphic illustration, the bar diagrams. They are also employed for showing comparisons. Bar diagrams are a series of horizontal bars or vertical bars drawn parallel to each other. Each bar can represent different items or the same item at different times. The scale can be a scale of percentage or absolute quantities. Therefore, in general, bar diagrams are ideal for showing comparisons between figures of the same item during different periods or of figures of different items during the same period. Sounds confusing? Well, it's not really confusing. Let's take the help of some examples. This bar diagram shows students' response to diploma in management in IGNOU. It is spread over a period of 5 years, and the number of students is in thousands, which is plotted on the y-axis. Take also a look at the key at the bottom, which shows that the red bar represents the number of students who applied, and the green bar shows the numbers who actually enrolled. In 1987, about 6,000 applied, but only 3,500 enrolled. In 1988, the number went up to 7,000 who applied and about 5,000 who enrolled. In 1989, there was a steep increase in the number of applications to a little above 20,000, but the number who actually enrolled increased very slightly to about 6,500. And then there is a drop, and again a rise in student applications in the next 2 years, 1990-91. But those who actually enrolled increased only very slightly to about 7,000 students. Now, this is a very simple reading of the bar diagram, but the reasons for this are not available in the bar diagram. Why such a steep increase in applications in 1989? Was it increased advertising? Why the figures for enrollment show very slight increase? So a lot of questions are raised on reading this bar diagram, whose answers can only be found through a more in-depth study of the matter. Well, we are able to read this bar diagram because now we are able to compare. But further explanations and ramifications, the whys and wherefores, can only be understood if we have a thorough knowledge of the subject. That is why an understanding of the subject becomes essential to form the whole picture. This is probably the reason why people unfamiliar with the subject might be in a position to decode the basics of the bar diagram, but are in not that strong a position to be able to comment and analyze. Well, till now we've been taking a look at some forms of graphic communication that deal with absolute figures and data. I think it's time we took a look at some which are a deviation from the above. Pie charts. A pie chart is a full circle representing a whole, with the various segments contributing to that whole. A pie chart is a pictorial representation of data generally presented in the form of percentages. A pie chart is percentage representation, and actual figures can be calculated from it. A pie chart, therefore, in general is used to show the degree of contribution by the parts to a whole. Let's try and understand this by means of an example. Let's take the example of a day in the life of an average student. The student can be in school or college. Now, every adult sleeps for around 8 hours on an average, which is 33.33% of the whole day. He attends classes for about 6 hours, that is 25% of the day. He spends about 2 hours in morning ablutions, dressing, bathing, changing, etc., which is another 8.33%. He spends about 2 hours in eating. Seems a lot, but think about it. Breakfast, dinner, tea, snacks. This is about 8.33%. In metropolitan cities, he spends about 2 hours in commuting from his house to his place of study and other places during the day. Another 8.33%. So after all these essential activities, he is left with exactly 16.66%, which is about 4 hours of the day. This is the net time available for study, recreation, sports, socializing, and any other activity he wishes to indulge in. If he takes out 2 hours for sports, recreation, socializing, then he is left with just 2 hours for personal studies. Hits you in the eye, doesn't it? Well, you probably never realized it until you looked at this pie chart. Well, that's the great advantage of graphic communication. It emphasizes things in a very forceful manner. Are you ready to practice with another pie chart? This one shows the world market share in the pharmaceutical industry. I would like to bring a point to your notice here. The sum total of all the percentages that you see on that pie chart is equal to 77.3%. I said before that a pie chart represents a whole, that is 100%. So what happened to the remaining 22.7%? Well, that is contributed collectively by countries who individually do not contribute enough to merit a position on an individual basis on this pie chart. So we can break it up here, and this is the way a final pie chart would look. Now let's take a look at this pie chart and try and analyze it. At first glance, it is clear that USA is the leader, contributing a major share of 28.3%. The next major contributor is Japan with 21.6%. India ranks second last with 1.6, followed only by Brazil. Another interesting observation that can be made is that USA and Japan together contribute about 50% of the world market. The Asian contribution of India and Japan of 23.2% is about the same as of Europe, which includes Italy, the United Kingdom, France, Spain, and Germany, contributing a total of 22.3%. So we can draw many other inferences from this pie chart too. So like a table, here too we can be selective. Well, that was interesting. Now let's move on to something that is even more interesting. Let's move on to flowcharts. Flowcharts are drawings in which Particular shapes and connecting lines are used to show how an action in a system is related to others. They are an excellent way of illustrating the steps of a process. Certain symbols are associated with flowcharts. Let's take a look at them. Terminal symbol, used to start or stop the flowchart. Input symbol, which shows what triggers off a decision or process. Process symbol, showing the meaning of what the operation is all about. Decision symbol, used to ask a specific question. The important thing to remember is that the answer should always be a yes or a no. Let's take a look at a flowchart. A flowchart of a person trying to become a model. Who can become a model? Can I become a model? Can some of my friends become a model? Let's see. We start with the start signal. Next comes an input. Take a good look at yourself in the mirror. Now a decision has to be made, an honest, introspective one. Am I good looking enough to be a model? If no, tough luck. If yes, well, go ahead. Good face. But do I have a good physique? Another question. Therefore, another decision box. If no, well, take remedial action. Go and exercise. Then try again. If yes, you are lucky. You already put in the hard work. Next, get photographed.
Smile, please.
This is a process, so goes in the process box. Are you photogenic? Do you photograph well? You might be good looking, but maybe you don't photograph well. Another decision box. No? Tough luck again. Yes? Well, go and get a portfolio made. A portfolio is a selection of your photographs in different looks, poses, and moods. Submit the photographs to advertising agencies and agents. Another process. Do you get a response? Another question. Another decision to be made. If no, well, maybe your portfolio was not good enough. Get another one made. If yes, well, work will eventually come your way, and modeling can be your future. Well, so much for flowcharts. Before we end this program, let's take a look at another kind of graphic illustration, pictorial representation. They are used as an aid to understand and assimilate what is written in the text. Let's take this piece, which shows how heat is lost from the human body. The deep body temperature must remain balanced and constant around 37 degrees Celsius. In order to do this, all surplus heat must be dissipated to the environment, etc., 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 etc. After reading the passage, maybe the information might not be easily assimilated in one or two readings. Let's change this around a bit. To maintain the body at an optimum temperature level of around 37 degrees Celsius, all the surplus heat that we receive from the sun, directly, through radiations, etc., must be dissipated. And this is done through evaporation in the form of sweat, exhalation, and insensible perspiration. Insensible perspiration is the perspiration that the human body is constantly doing to maintain its thermal balance with its outside environment. Through convection by the flowing breeze, through conduction directly into the ground through our feet, and through radiation. Don't you think now it would be so much more easier for you to understand what is written in the text? And this is a point that I would like to emphasize with regards to all the different kinds of graphic communications that we have been seeing in this program today. Graphic communications aid in understanding and assimilating the information provided. but by themselves are not always enough to assimilate or grasp the subject matter in all its totality. Sometimes a specialized knowledge of the field is also necessary. But most of the time, all you need is an attentive mind and a logical understanding of how to decode graphic communications. So here is wishing you all a very good luck.